are in Generalized Linear Models with Examples in R, that book right there. Chapter 3, question 3.16. Okay, so here we are going back to a familiar data set called blocks. I think this has come up at least twice so far. So in chapter 2, in the questions there, we fit a regression with this data. And now we're going to perform a diagnostic analysis on this. And then apparently it's going to show us very poor fit. And so we are going to transform our data and then refit it and run another diagnostic analysis on it. So first thing we need to do is get that regression up. And so we need to install the GLM's data package, load the package, call up the data blocks, and I'm just relabeling it D here. And when I go back to my question 2.18, I used this as the regression, although there's several different possible regressions that could have been done, and I don't think it really matters here. So whatever you used in 2.18 is just fine. I think that the back of the book answer just regresses on shape, but it's fine. So let's perform our diagnostic analysis. Again, we could get in more depth, and we've gone into more depth in some of the above problems for our diagnostic analysis, but usually just plotting. You put plot and model, and the plots that come out are, a good first approximation here. And so we run this, and let me just zoom in here. Okay, so when we run this, we see quite a few things here. We see kind of some clustering here. I imagine that has to do with shape, because I think there's only two possible shapes that we can have. Okay, so we see the residuals kind of, well, I guess the observations kind of fit into two nice bins here. And then we also see on the QQ plot that we are kind of quickly spiraling out of control as we get into these larger quantiles here. So that suggests that maybe we could get a better fit if we transformed our data, which is what the question suggests. And so the first one I'm going to try here is the log. I'm just going to log time here. Okay. There's others that we could do, but square root or whatever. But I'm just going to use the log transform here. So I run this, and I'm going to check out its plot, okay, or it's a diagnostic plot, and we see much better fit here on the QQ norm plot, and I should have paid more attention to the residuals versus leverage, or brought more attention to it, to this plot, but this plot is actually doing much better at eliminating kind of some bizarro residual leverage juxtaposition. Well, yeah, there's a comparison right there, right? So you just compare the scales here, and you quickly notice the difference. But anyway, so that's fine and good. And just to kind of show that that the second model is fitting better, I've ran the AIC on the two models. Remember, a lower AIC means typically a better fit, and the better fit is definitely coming on this log transformed model. Okay, so I guess we'll call that good there.